In this video, we will be applying the quadratic formula, and these are basic examples, and there will be another video for the advanced examples. Okay, so this is the quadratic formula. First, it comes from a standard form of an equation of a quadratic, so ax squared plus bx plus c. These are the same a, b's, and c's right here that we're talking about. So the number in front of the x squared is the a, the number in front of the x is the b, and then the number by itself with no x next to it is a c. So in this problem, we've got a, b, and c. Okay, so a is equal to 5, b is equal to -5, and c is equal to -1. Okay, so I'm going to write down the quadratic formula. I'm going to leave spaces to put the numbers in. So I get x is equal to -b. I'm not going to put it in there yet, just little parentheses, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so I'm just going to put the correct numbers. This is the b. Okay, so our b is -5. Okay, this is also b, so -5. This is a, so 5. C, -1. And this is a, so 5. Okay, and now I will simplify this. Okay, so we've got two negatives sitting here. They cancel, so that gives us 5 plus or minus the square root of -5 squared. This is why I put it in parentheses, because it's -5 times -5, which is +25. If you don't use the parentheses then and try to use it in the calculator, it might not give you the right answer there. But this is +25. Okay, let's see, we've got minus 4 times 5 times -1. Okay, so the negatives will cancel each other out, and the 1 doesn't really do anything now, so it's just 4 times 5, which is 20. Okay, and on the bottom we get a 10. Okay, let's see, so that's x equals 5 plus or minus the square root of 45 over 10. Okay, now can we reduce that square root of 45? Well, we can reduce square roots by dividing out square numbers. Your square numbers are going to be 2 squared, which is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, and you can keep going, but one of them does go in there. The 9 divides evenly into the 45. So we can say this is the same thing as 5 plus or minus the square root of 9 times 5. 9 goes in there 5 times over 10. And now since 9 is a number that we can square root, we square root the 9, which becomes a 3. So x is equal to 5 plus or minus 3. Leave the 5 on the inside over 10. And I'll do this once. I'm not going to do it every time, but if you want to split it up into two separate answers, it would be 5 plus 3 square roots of 5 over 10. And then the other answer would be 5 minus 3 square roots of 5 over 10. Okay, let's look at our second problem. Okay, in this problem we have 2x squared plus 7x minus 5. So it's the same. Our a is going to be 2, our b is going to be 7, and our c is going to be -5. Okay, so we put that into the quadratic formula. So x is equal to -b, so our b is 7, so -7, plus or minus the square root of b squared. So in parentheses, I'll put the -7 and I'll square it. Okay, and minus 4 times our a, which is 2, times our c, which is -5. All divided by 2a, so 2 times 2. Okay, I'm going to clean this up some. Okay, so we don't need the parentheses anymore on that, -7, so I can just leave it like that. Plus or minus square root. -7 squared is +49. Okay, and this, -4 times -5 would be a +20, and +20 times 2 is +40. And on bottom we get a 4. Okay, so that will become -7 plus or minus the square root of 89 over 4. Okay, so we could try our square numbers in this. So 4, 9, 16, 25, 36, 49, and so on. You could try those, but none of those are going to divide into 89 because 89 is prime. This is a prime number, so this cannot be reduced anymore. So this is your solution, and if you wanted to split it up into two solutions, do one with a plus and do the other one with a minus. Let's look at another one. Okay, on this one I have 8x squared plus x minus 3. Okay, so our A is 8. Our B is the number in front of x, and since there's not a number written there, I'll put a 1. And our C is that last number, so C is equal to negative 3. Okay, so x is equal to negative B, so negative B, negative 1, plus or minus square root of B squared, so that's going to be 1 squared, minus 4 times A, which is 8, times C, which is negative 3, all divided by 2 times A, which is 8. Okay, we can clean that up some. So here's negative 1 plus or minus a square root. 1 squared is just 1. Okay, and then let's see, this is going to be a positive again because we're multiplying a negative times a negative. So this is going to be 4 times 8 is 32, times 3 is 96. So plus 96 over 16. And that will end up giving us negative 1 plus or minus the square root of 97 over 16. And just like the last problem, we could try to reduce this, but 97 is a prime number, so we can't go any further with this. Let's look at one last example. Okay, for this last example, we have 7x squared minus 3x minus 2. So our A is the number in front of x squared, so 7. Our B is the number in front of x, which is negative 3. Okay, and our C is this number by itself, which is negative 2. Okay, so x is equal to negative B, so negative negative 3, plus or minus the square root of B squared, so that's negative 3 squared, minus 4 times our A, which is 7, times our C, which is negative 2, all divided by 2 times A, and that's a 7. Okay, so if I clean this up, first of all, negative times a negative will give us a positive 3, plus or minus the square root. Negative 3 squared is positive 9. And let's see, negative 4 times negative 2 is 8. And then 8 times 7 is 56. Okay, so plus 56 over 14. Okay, and that would be 3 plus or minus the square root of 65 over 14. Okay, all right, so this one also cannot be reduced any further, but it's not because 65 is prime. It's because that none of the square numbers go into it evenly. Remember, your square numbers are 4, 9, 16, 25, 36, 48, or 49, excuse me, and 64. Okay, you can try dividing each one of those in there, and you will get none of them will actually go in there evenly, and that's because this is a product of a couple of prime numbers. Okay, and that's it for the video.